So although you are quite familiar with the study area, but it is necessary to understand the relevance to study these things. So, when we talk about the Indian road network, it is the world's second largest road network, which comprises of more than 6.2 million kilometers of the road. Although more than 90% of the roads are made up of flexible pavements, but today the concrete pavements are emerging as well, because their life, although their initial cost is more, their maintenance is quite negligible, and their life cycle cost is relatively lower than the flexible pavements. So currently, as the rate of the road construction of national highways are increasing at a tremendous rate, and in last 5 years we have seen a growth of more than 250% in the development of national highways. On the same time, we are also seeing a tremendous growth in the construction of rural roads as well, which comes under the domain of the Pradhan Mantri Gram Sadak Yojana. Recently, the Indian government has decided to construct their national highway with the cement concrete as the default option, because as I have already told you, although the road construction cost of a cement concrete pavement is about 20% higher, the overall performance of the cement concrete pavement is very good, and the life cycle cost is about 30 to 35% lower. So it is essential that you should aware with the quality control test of the cement as well as of the concrete. So let's start with the most important component of the cement concrete, that is the cement itself. So when we talk about the cement, in a general sense, we can say it is a material which shows both adhesive and cohesive properties. And it not only binds the inert aggregate together, but also fills the gap between them or densify them. So with these two properties, the strength of the concrete is more or less depending on the quality of the cement and the quantity of the cement. When we talk about the cement itself, then we can classify cement in two categories. The first one is the hydraulic cement, and second one is the non-hydraulic cement. So the difference between the hydraulic and non-hydraulic is reflect in its words itself. The first one is hydraulic cement, so it reacts with the water, which generates a hydration reaction, which tends to form cement calcium silicate hydrated gel that provides the strength in the concrete. On the other hand, on the other hand, the non-hydraulic cement doesn't react with the water, doesn't require water, or rather it's unstable in water. Such cement, the example of such cement is plaster of Paris. And the example of a hydraulic cement is ordinary Portland cement. So the cement has two primary components.
Uh,
Hello?
there is some background noise. Like, means, can you just shut down the doors and the windows if it is possible?
Uh, just a minute, sir. Sir, is there any improvement, sir?
Okay, no problem. If something is there, means whatever the best you can do, probably you have done. No problem. So maybe you can slightly raise your volume or pitch so that you are more audible.
Just a minute, sir. Let me try, sir. Okay, sir. Is it better, sir?
Yes, definitely.
Okay, sir. So, as I as I as I was speaking, there are two primary components of the cement, or primary raw materials of the cement, that are calcareous material and the argillaceous material. Calcareous material are the material that are calcium rich, such as limestone. Argillaceous material are the material that are clay rich. So cement is comprises by the fusing these two material together, and rather the man-made cement is formed by fusing these two material together at very high temperature of a range of 1200 to 1450 degrees Celsius. On the other hand, there are some natural types of cement as well, such as Roman cement and Medina cements, which are formed by the crushing the fine aggregates that inherently have the cementitious properties. So as we mix the finely ground calcium rich or calcareous material and the argillaceous material together at very high temperature, they fuse together to form a homogeneous component known as the clinker. And by crushing this clinker together and adding a small amount of gypsum to it, we comes across with the product which is known as the artificial cement or the ordinary Portland cement. So the composition of the concrete comprises of the components such as active components that are cement and water. Then we also have the inert components such as crushed aggregate, or coarse aggregate, and the sand. And also, we intentionally provide some amount of air to the concrete as well. And if we want to deliver some special properties to the concrete, then we will add some another component known as the admixtures. Now, ordinary Portland cement is the most common type of the cement. The name is ordinary Portland cement because its property, when it sets, it resembles the properties of a aggregate which is quarried from the quarries of the Portland in UK. That's why it is named as the ordinary Portland cement. Now, ordinary Portland cement are of three grades: 33 grade, 43 grade, and 53 grades. And more or less, the most of the properties of all three grades are same, although the primary difference between the properties is the compressive strength. When we mix this cement, one part of a particular 33 grade cement, and with the three part of the standard sand, and form a mixture, form a cube of the size 100 by 100 by 100, it should give, after the 28 days curing, a strength of 33 megapascal. So similarly, 43 grade cement gives the strength of 43, and the 53 grade gives the strength of 53. Although in the current scenario, 33 grade cement is usually, right now the 33 grade cement is, government has not been utilized 33 grade cement, and right now 43 and 53 grade cement is only utilized for different purposes, specifically in the pavement construction. So this is the simple, it is a rather a detailed flow chart of the process of cement production. So first we need to ground the calcareous and argillaceous material together in a fine powder form. Then we need to heat them at a very high temperature of 100, in the range of 1200 to 1450 degrees Celsius. When they mix at this, when we mix these components in a very high temperature, they fuse together to form the clinker. When the clinker cools down, we ground the clinker along with the 4% of the gypsum so that our flash set doesn't happen in the cement. Okay. So the fine product that we received after the mixing with the gypsum, we called it as a cement. We packed that product into the airtight bags and delivered to the site where it has been used. So the performance of the cement and performance of the cement controls the performance of the concrete, and the performance of the cement is directly related to the chemical composition of the raw materials. In an ordinary Portland cement, there are four major oxides that affect the over their performance in various aspects. These major oxides are calcium oxide or CaO, then silica oxide or SiO2, then Al2O3 or aluminum oxide, or finally the iron oxide. Other than that, we have some minor oxides such as MgO, Na2O2 and K2O, TiO2, phosphorus oxide, and SO3 as well. However, the major oxides controls the most of the performance of the cement. So calcium oxide is that oxide which has the largest composition in the cement. So it directly controls the strength as well as the soundness. Its deficiency although reduce the strength and setting time, but if it is in excess, it will also degrade the soundness of the cement, or cement will suffer the cracking. So its composition should be limited in the range of 60 to 65%. The second major oxide is silica oxide, which is responsible for providing strength. However, the excess of it will cause the tends to increase the setting time of the cement, reduces it reduces the development of strength in the cement. Then Al2O3, it is responsible for the quick setting. Although if it is in excess, it also lowers down the strength. If Al2O3 are very are in accessible amount in excess amount, then it would also lead to the development of cracks in the cement. And finally, Fe2O3 is majorly responsible for the color of the cement, and it helps in a fusion of different ingredients. So it basically acts as a catalyst. When the primary oxides combines together at very high temperature, they form a very complex compound, and these complex compound reacts with the reacts with the water to generate hydration reaction that tends to develop the strength in the cement. These complex compounds are majorly known as the Box compound, as it was discovered by R.H. Box. Now, there are four major types of Box compound known as the halide, baelite, silicate, and ferrite. Now, the halide is a combination of three part calcium oxide or 3CaO and one part of silica oxide. Similarly, baelite is known as the dicalcium silicate, silicate is the tricalcium aluminate, and tetracalcium aluminiferrite is known as the ferrite. Now, relative composition of these all components affect the overall performance of the cement. So first we have to know about the hydration reaction. So hydration reaction is a reaction which happens between the cement and water when cement comes into contact with water. It is an exothermic reaction. So what happens? This equation shows the reaction. So when a Vogue compound comes in directly contact with the water, it forms calcium silicate hydrate gel, which is responsible for providing the strength of the cement as well as to reduce the porosity. Similarly, when this reaction happens, we also have a byproduct in our disposal, that is calcium hydroxide or CaOH whole twice. Calcium hydroxide doesn't contribute to the strength, although it provides alkalinity to the cement, which might helpful in resisting the corrosion in the reinforcement. Other than that, calcium hydroxide is a byproduct, so it doesn't contribute in the strength, and it is sometimes it also produce the permeability. It also increases the permeability in the concrete when it dissolves in the water. So the box compound, when it comes directly contact with the water, generate calcium silicate hydrate gel, which directly affect the impermeability as well as the strength of the cement and the concrete. Now, each type of the box compound has direct relation with the performance of the cement. The first compound, which is in the largest quantity, is Tricel calcium silicate, which we know as the halide. So, halide comprises about 25 to 50% in the cement composition, and it contributes to the early strength of the cement. So, the strength that we are receiving after the 7-day and after the 28 days is mostly generated by the reaction of the halide with the water. Okay. Now, the heat of the hydration of halide is also relatively low as compared to the aluminates and ferrites. So it doesn't generate that much shrinkage cracks in the cement as well. Similarly, dicalcium silicate is also another Vogue compound which is responsible for the strength, but it is responsible for the lateral strength. Its composition is about 25 to 40% of the total weight of the cement, and it contributes to the later strength because its rate of reaction is relatively lower as compared to the halide. So the later strength, rather the strength which is produced after the after 28 days or even after the 1 year, it is basically due to the dicalcium silicate. Overall, tricalcium silicate and dicalcium silicate both contribute almost equal amount of strength to the cement. Then third thing is tricalcium aluminate, which is responsible for the setting of the cement. The tricalcium aluminate or Sealite, it is responsible for the setting of the cement, and it also produces high heat of the hydration in cement. If we increases the C3A content, it will reduce the setting time, but similarly, it weakens the sulfate attack of the cement as well, and and it reduces the durability of the overall concrete. Similarly, it also reduces the ultimate strength and the contraction during the air hardening. Final component is tri-tetracalcium aluminoferrite, which is in the lowest composition. It is about around 9% in the cement. It is responsible for the flash set, but it generates less heat as compared to the tricalcium aluminate. Although it doesn't have any cementing properties, so it doesn't contribute to any strength. Now, when we talk about the types of the cement, the relative composition of all these four components that we have already discussed, along with some additional components, determine the performance of the cement. So there can be many types of the cement ranging from OPC or ordinary Portland cement and rapid hardening cement. In rapid hardening cement, we usually grind the cement. Uh, we usually grind the cement much higher so that uh, it reacts at a much greater rate and develop strength in a very earlier time, in a very less time. Similarly, we have other types of cement such as extra rapid hardening cement, Portland slag cement, quick setting cement. But if we talk about in the context of the pavement construction, the OPC is the most widely used cement, along with the Portland slag cement and Portland pozzolana cement. These all three cements are usually permitted by the Indian Road Congress specification. Then let's move to the testing. Then when we talk about the testing of the cement, we can differentiate testing in two parts. The first one is the lab testing, second one is the field testing. So first of all, we will have an overview about the field testing of the cement. So when we talk about the field testing, these are the list of the most common tests that we usually perform while checking or while purchasing the cement. The first one is the adulteration test. So it's a quite simple test. We take a sample of the cement from the bag directly. We rub the sample between our fingers. If cement is smooth, it is good. But if it is gritty in nature, then we should discard it. The second test is a color test. So the color of the standard cement should be uniform and it should be gray and have a tinge of a greenish shade. However, if the color is non-uniform, it simply means that the cement is starting to react the atmospheric moisture, and that's why its color is going to change. So we can discard cement by checking its color as well. Then the date of the manufacture test. Usually it is recommended that the cement should be consumed within 90 days of its days of 90 within 90 days after its manufacturing. Because after that, although we are providing cement in a airtight bags, it usually reacts with its surrounding atmosphere and it tends to form lumps. And also the strength produced by the concrete using this cement would be relatively less as compared to the fresh cement. Then the lump test. In the lump test, we take a bag of the cement, we spread the entire bag over the cemented or the brick rocks, and we will observe the uh, texture as well as the presence of any lumps in the cement. If there is the lumps, we should discard the cement because it has already been reacted with the surrounding atmospheric moisture. Then the smell of the cement is in the smell test. If you take some amount of cement and smell it slightly, then if you receive the earthy smell, it's clearly suggested that it contains adulteration in the form of silt and clay. Then the temperature test. If you immerse your hand into the bag of the cement should feel cool, not the warm, because we already know the hydration reaction is an exothermic reaction. So if the temperature of cement is high, it simply states that the cement has been reacted with the surrounding atmosphere, and that's why the temperature increases. And then the float test. If you put a small amount of cement onto the surface of water, it it should not directly sink, but it should remain afloat on the water surface for a while. And finally, the setting test. In the setting test, we take a small amount of cement. We put the cement on a glass plate, mix a small amount of water with it, and submerge the paste under the water for 24 hours. The cement, after the 24 hours, we took out the plate and we observed the surface of the paste. The cement paste should be set, but it should not generate any cracks on it. If there are some cracks on it, then it clearly suggested that the cement is not good. Now, after the field testing, we move towards the laboratory testing. So, laboratory testing, there are some specific properties that we need to test in order to make a comment over the quality of the cement. So, I have mentioned a list of the tests. The first one is the specific gravity test. So, specific gravity, as you have already studied the bituminous, as you have already learned about the bitumen, so you might be familiar with the specific gravity. So, basically, specific gravity is a ratio of the mass of a given volume of the material to the mass of the equal volume of the water at the standard temperature. What is the role of the specific gravity? When you perform the concrete mix design, as per the IS 10262 or as per IRC 44, whichever code do you follow, you need to follow. You have to perform the mix design. You have to perform the mix design considering specific gravity in analysis. Because if you want to do the volumetric calculation, specific gravity is the parameter that converts the weight of the material into the volume. So specific gravity test is a must. And the cement has a and every type of a cement has a specific range of the specific gravity. Then the fineness test, as the hydration reaction is directly depending on the surface area of the cement. Since if the larger surface area of the cement comes in contact with the water, then it would react better with the water and generate calcium silicate hydrate gel in a lesser time. So the finer will be the cement, the higher will be the rate of the hydration. So in order to generate early strength, we need to use the cement that has a particular fineness to it. Okay. Then the consistency test. Consistency test. Consistency test doesn't show any standard performance characteristics, but it is an essential factor which is responsive, which you require to perform the setting time, soundness, and the compressive strength test. When we test the paste of the cement, you need to have you are it is required that the paste has some standard solidarity or standard consistency. So since the properties of different cements are different, the water requirement to generate the standard solidarity must also be different. So for each specific type of the cement, you need to determine the standard amount of water which will produce the paste of the standard solidarity, and that amount of water will further be used to perform the setting time test, soundness test, and the compressive strength test. So the consistency test is the must. Then the setting time test. The setting time tests are also divided into two categories. The first one is the initial setting time and second is the final setting time. As soon as we mix cement with water, it reacts with water and starting to produce hydration reaction. So after some times of the mix after the mixing process, the cement paste is loses its plasticity and it will no longer will be moldable in nature. So the time after which the cement paste loses its plasticity is known as the initial setting time, and the time after which the paste become the hard mass or it was able to bear some pressure, it is known as the final setting time. Then soundness test. Soundness is the property of the cement to soundness is rather the ability of the cement to retain its volume after it's get hardened. If after cement gets hard, if it tends to further expand its volume, it generates cracks on its surface which deteriorate the performance of the cement as well as the concrete. So cement should be very sound in nature. Then compressive strength test. It is quite simple. It provides the indication of ability of cement to make the concrete strong in compression. So before performing any test, we need to take a representative sample for testing. So in order to take the representative sample, you have to take sample from at least 2% of the bag that are available in your sublot. So you have to choose the randomly a minimum 5 number of bag from the sublot. Okay, then you have to use the sampling tube. You have to use a sampling tube which picture I have already mentioned. Then the sampling tube should be inserted diagonally to the into the bag, and then you have to withdraw the sample from the bag. And this sample should be you should preserve this sample into the moisture proof container, and from different bags you have to take different types of sample, different quantities of the sample, and all samples should be further mixed into the moisture proof container. And when you are going to perform the test, you take a smaller sample from the moisture proof container, and that sample you should pass through 90 micron IS sieve, and the lumps that you are observing on the 90 micron sieve, you should discard that lumps, and the sample which passes through 90 micron sieve should be used for your further testing. So the detailed procedure is available in IS 3535 1986. I have already provided the link. As sir will share the slides with you, you can directly download this code from this particular link. So let's discuss test one by one. The first one is the specific gravity test. So there are two ways to perform the specific gravity test. The first and the most popular way is using the Chatlear's flask. Other than that, you can perform this test using density bottle as well. So standard condition for testing is the testing should be conducted at a temperature maintained at 27 plus minus 2 degrees Celsius. Okay. Now, testing specification is IS 4021 Part 11, 1988. And these are the apparatus which we required to perform the test. This is the Chatlear flask, then weighing balance, gauging troubles. We need to perform the test using the kerosene because kerosene is non-reactive with cement, and since we need to maintain the temperature at a range of 25 to 29, we need to perform test with the help of water bath. So you need to make sure that your flask is completely empty and completely dry, and then you have to fill the kerosene or naphtha to the point on the stem between 0 to 1 ml. So up to this point you have to fill the kerosene. After that, you have to insert the flask into constant temperature water bath, which is maintained at the room temperature, and variation greater than 0.2 degrees Celsius should be avoided. At this point, you need to measure the initial reading of the flask, which we can represent as V1. Now put a standard quantity of cement, say 60 gram of the cement, into the flask, and you have to note the rise in the kerosene level. Suppose kerosene level rise to up to 22 ml mark, so you have to note the rise as well. Then after that, you have to tilt the flask. You have to put the stopper and then tilt the flask to an acute angle and roll it over to the tabletop, so that if any cement get adhered on the walls of all the walls of the flask, they should get displaced in the kerosene. At the same time, you also need to make sure that the air bubbles, air should be completely removed from the cement sample. After that, you will read the final reading as V2, and you can calculate the specific gravity of the cement by the formula S equal to W1 by W2. So W1 was the initial weight or 60 gram weight that you have already taken. W2 is the weight which is equal to the mass of the equal volume of water, which you can calculate by multiplying the change in the volume with the specific gravity of water. So using this formula, you can calculate the W2, and W1 by W2 would be the specific gravity. Now, as specific gravity is the dimensionless unit, so you should also take care about the units as well. So similarly, the similar test can also be performed using the density bottle or a specific gravity bottle, whose picture I have already mentioned here. Now, during the testing, you have to perform this test twice, and should report the average value. Okay, if the difference between two values is more than 0.03, the test should be repeated. Now the standard value of the OPC, specific gravity OPC, is usually 3.15, and that of the Portland slag cement and PPC is 2.90. Then the next test is fineness test. Now the fineness test can be performed with the help of simple sieving, or it is also performed using the Blaine's air permeability method. However, in this presentation, I have not mentioned about the Blaine's air permeability method, but if you want to study about that, then the quote is available, that is IS 4031 Part 2, 1996. However, this test is performed with the help of, as per the code IS 40231 Part 1, 1996, and it assesses the quality of the grinding of cement in terms of the amount of grit that is written on the standard sieve. If cement is not properly fine, then the concrete that we are produced with the help of this cement will show the less strength as well as poor workability. And if we try to increase the workability by adding the additional water, it would lead to the bleeding. So the procedure is quite simple. You weigh around 100 grams of the cement and break down any air-set lumps if it is present. Then you have to perform the sieving. In a clockwise and counterclockwise manner. In between, you have to tap. Sieves as well. So you have to perform the process for 10 minutes so that no fine material passes through it. After that, you will collect the residue using the brush, and we will weight the residue. If sorry, if the residue exceeds 10% for the ordinary Portland cement, then you should discard that cement sample. Similarly, if the residue exceeds greater than 5% for the rapid hardening Portland cement, you have to discard that sample as well. So the maximum allowable uh, residue is for the ordinary Portland cement or OPC should be 10%. Okay. So as I have already told you, this test can be performed using air permeability method or Blaine's air permeability method. Other than that, you can perform test as with the help of Wagner's turbidity method as well. The third test is the standard consistency test. The standard consistency test gives you the amount of water which you needed to add to cement to produce a paste of the standard solidity or normal consistency. So this amount of water will further be used to perform the tests such as initial setting time, final setting time, soundness, and compressive strength test. So before performing these particular tests, you need to determine the amount of water that produce the paste of the standard consistency. So first, how can you define that? How can you define the term standard consistency or normal consistency? So standard consistency can be defined as the viscosity which permits the Vicard plunger of a standard weight having the diameter of 10 mm diameter and 15 mm length to penetrate into a depth of 33 to 35 mm from the top of the mold at the standard condition. The standard condition is quite essential. You should have to perform this test at a relative humidity of 65 plus minus 5% and at a testing temperature of 27 plus minus 2%. The testing specification is IS 4031 Part 4, 1988, whose download link I have already provided. So this is the schematic of the Vicard plunger, Vicard apparatus rather. So Vicard apparatus has three different attachments. These are the attachment, number 1, number 2, and number 3. This is the Vicard plunger, which is used to determine the standard consistency. The second one is the Vicard needle, which is used to determine the initial setting time. This is the what I can say, Vicard plunger as well, modified needle. So it is also used for determining the final setting time. Other than that, the instruments are same: the stopwatch, gauging troubles, and weighing balance. So for the testing, you have to take a standard sample of 300 grams of the cement. Then 26% is a good starting point. So take about 26% by weight of the dry cement and mix it thoroughly. 26% water by weight of the dry cement, and you should mix it thoroughly. You should take care that the gauging process should be complete within 3 to 5 minutes. Okay, so after the completion of the gauging or mixing, this standard paste should look something like this. After that, you have to fill the Vickart mold, which is resting over the glass plate or any other non-porous surface. You have to fill the sample up to the brim. You have to clean the sample that is on the outside outer edges of the Vickart mold. And similarly, you have to give a small tapping as well, so that if there is any air in between the paste, it should expel out. After that, you should set up the arrangement, set up the apparatus, and install the Vickart plunger. And you should adjust the level of the apparatus up so that the plunger touches the top surface of the mold. After that, with the help of the release button, you just release the release the Vickart plunger, so that by the influence of the gravity, it penetrates to the uh, mold. If the so the needle, this is the needle, this is the graduation which is mentioned on the Vickart apparatus. So as the plunger moves downward, you can simply read the reading. So if the reading falls in the range of 5 to 7 mm, you have to notice that the readings are increasing from lower to the upper point. So if the reading falls in the range of 5 to 7 mm, then your paste is in the standard consistency or the normal solidity, standard solidity. So the water that you have added is good enough, and you can consider as the standard consistency. But if the reading is greater than 7 mm, it means that you need to increase some amount of water in your next trial. And if the reading is less than 5 mm, then you have to decrease the water content in the next trial. So you can just plot a typical graph between the water percentage and the penetration of the Vickart needles. And finally, you can determine the consistency of the cement by determining by considering the water content in which the penetration falls in the range of 5 to 7 mm. Few things you have to taken in mind while doing this test. First one that I have already mentioned, the humidity should be standard at 90%, and then and the temperature should be in the range of 27 plus minus 2 degrees Celsius. Then during the release point, you should not apply any pressure to the plunger, or you should not apply any jerk to the plunger. Other than that, you should not use the same sample. You should not use the same sample, but you have to make fresh sample every time you have to repeat the test. Then after we determine the standard consistency, you have to determine the initial and final setting time of the cement. So initial setting time basically gives you the time period so in which you can just complete the processes such as the mixing, transporting, placing, compacting, and finishing. So during this period, the cement doesn't lose its plasticity, or rather it should have a minimum plasticity in your at its disposal, so that it doesn't get hard and moldability can be possible. However, after you complete the moldability, you need to uh, require that the cement should lose its plasticity as early as possible time, and you should able to apply some pressure to it. So the time after which the cement completely loses plasticity, so that its durability is increased and it is less vulnerable to the damage from the external agency, that time is known as the final setting time. Okay, so final setting time and initial setting time is tested with the help of as per the instruction given in IS 4031 Part 5 specifications. And for that, similar to the consistency test, you have to take 300 grams of the sample and you have to perform the gauging process. The procedure is somewhat similar in the initial steps. And then instead of the Vickart plunger, you need to insert the Vickart needle to the arrangement. You need to install Vickart needle to the Vickart plunger, to the Vickart apparatus. And after that, you need to measure the penetration of the needle for every 5 minutes until the penetration from the top falls in the range of 35.5 to 34.5 mm. So you have to perform this test for every 5 minutes, and after every 5 minutes, the time after which the penetration falls in the range of specified range, then you can consider that time as the initial setting time. Similarly, in the final setting time, you not have to mix the new sample, and rather you can utilize this particular sample for the determination of final setting time. So in the final setting time, you just replace the needle of the Vicart apparatus with the annular arrangement, and this is the annular arrangement. If you see it carefully, there is a amount of protrusion in this annular arrangement. So basically, in a final setting times gives you the time in which the cement becomes completely hard or where it loses the plasticity. So what you have to do, you after a suitable time, you have to uh, you have to bring the annular arrangement close to the surface of the Vicart mold, and then you have to release the plunger or arrangement. So if the cement doesn't lose this plasticity, you can see the impression made by the attachment is something like that. But after some time, when the cement loses the plasticity, you will observe the central dot, which is due to the protruding end of the attachment, but the outer periphery of the attachment would not be visible. So at this point of time, or after this much amount of time, you will consider this time as the final setting time. So experiment should be conducted similar to the initial setting time at 27 plus minus 2 degrees Celsius. For the Portland cement, the initial setting time should be greater than 30 minutes, and final setting time should not exceed 600 minutes. There should not. There is some. Okay. For quick setting cement, the initial setting time should be greater than 5 minutes, and final setting time should not exceed 30 minutes. Then let's move to the next test, which is the soundness test. Now, soundness test can also be performed using two methods. The first one is the Chatlear's method, which we are going to discuss today. Other than that, there is another method known as the autoclave test. So autoclave test, we will not going to discuss, and we will focus our attention toward the Chatlear method, which is the more common method. So as we have already discussed, the axis of the free line make the cement more unsound, or rather tends to increase the volume of the cement after it's getting hard. So when cement is set, if it tends to increase the volume by its own, it tends to generate the cracks on its surface, which deteriorate the quality of the concrete. So we need to use the cement which is sound in nature and doesn't show any expansion after being set. Okay, so for this test, you need a Chatlear apparatus, glass plate, weights, caliper, and water bar. And this test is performed as per IS 4031 Part 3 specifications. So this is the Chatlear apparatus, this is the weight, this is the glass plate, and this basically we need to measure the distance between these two ends. So what we have to do, we need to prepare a paste by mixing 200 gram of cement with 0.78 times the water required. So this is important. The water required should be the 0.78 times the water required to give the standard consistency. Okay, so you need to place the Chatlear apparatus on the glass plate or another non-absorptive surface, and then you have to fill the paste and level the top surface. Then using the another glass sheet or other non-absorptive surface, you have to cover the top end as well, and then you have to place a small weight over the glass fiber sheet, and then submerge the entire assembly into the under the water at the temperature maintained at the standard conditions. That At the initial stage, you have to measure the distance between the indicator points that I have already showed you. And after 24 hours, you need to measure the distance between these points as well. Okay, so when when the entire arrangement is submerged under water, you need to bring water to the boiling point in a 25 to 30 minutes and keep it boiling for 3 hours. During this period, after this period, you have to remove the mold, you have allowed it to cool, and then you have to again measure the distance between the indicator points. So if cement is unsound in nature, then the distance between these two indicator points will automatically increases. So we need to determine the uh, difference between the indicator points before and after the experiment. And if the difference between the indicator points L2 and L1 is high, then the cement can be considered as the unsound cement. And in any case, this expansion should not exceed greater than 10 mm. So I will try to show you the experiment. I have a small video with me, so I think you can understand it better.
Let us see the procedure of soundness test by lead Chatlear method. Let us see the apparatus required for lead Chatlear test. Lead Chatlear test is used to find the excess of lime in cement. Prepare a cement paste by adding 0.78 times the water required to give paste of standard consistency. Lightly oil the lead Chatlear mold and place it on a lightly oiled glass sheet. Fill the mold with the prepared cement paste. In the process of filling the mold, keep the edge of the mold gently together. Cover the mold with another piece of lightly oiled glass sheet. Place a small weight on this covering glass sheet. Submerge the whole assembly in water at a temperature of 27 plus or minus 20 degrees Celsius and keep there for 24 hours. Remove the whole assembly from water bath and measure the distance separating the indicator points to the nearest 0.5 mm, that is L1. Submerge the mold again in water. Heat the water and bring to boiling point and cool down to room temperature. Measure the distance between the two indicator points to the nearest 0.5 mm, that is L2. Soundness of cement is equal to L1 minus L2. Standard specification. This must not exceed 10 mm for ordinary, rapid hardening and low heat Portland cement.
So I hope you get an idea about the soundness test using the animation. Then the final test about this of the cement is the compressive strength test. So in compressive strength test, you have to determine the compressive strength of a cement sand mortar which you produce by mixing one part of the cement with 3 parts of the sand, standard sand rather, and after 3 and 7 days curing. So compressive strength test is essential for grading as well, and also to determine the quality of the cement. So it is standard compressive strength test is usually performed with the help of the cube of 100 by 100 7 by 7 by 7 centimeter with a testing specification, and the testing specification which is followed is IS 4031 part 6 1988. So these are the equipment required for the testing: vibrating machine, weighing balance, gauging trouble, mold and compression testing machine. So the procedure, this is the procedure. In the procedure, you have to take 200 grams of cement, mix it with 600 grams of the standard sand, conforming to IS 650 specification. The water content that you need to mix should be taken as P by 4 plus 3%, where P is the standard consistency of the cement. And then you have to place the mold on a non-absorptive surface, and then you have to fill the sample, and then you have to uh, insert the, you have to use the, using the vibrating machine, you have to ensure that entire mold is filled completely with the specimen. And then after the filling of the mortar in the mold, then you have to remove the mold, and then completely and then you have to submerge it under the clean and fresh water, potable water, and keep it there until the time you are going to perform the test. So until that time you have to keep the cube wet till they are placed in the machine for testing. Now, one thing you should keep in mind while performing the test, you need to apply a uniform load. You need to apply a uniform load in the with the help of the machine, and you shouldn't provide any eccentricity to the load during the loading. So in order to avoid the eccentricity, you have to extract the mold from you have to extract the sample from the molds, and you have to place the sample along their side, because the sides are usually smoother as compared to the top surface. So when you apply the load along the sides, or rather when you turn the sample and then apply load over this side, then you will face no eccentricity. The load should be applied at the rate of 35 megapascal per minute, and compressive strength should be shall be the average of the compressive strength of 3 cubes in each period. So you can, for ordinary Portland cement, you can perform this test after the curing of 3 and 7 days. In the rapid hardening Portland cement, you can perform this test after 1 and 3 days, and low height Portland cement, you can perform the test after 3, 7 and 28 days. Now, you have to make sure that the mortar that you are inserting in the mold should not be compressed with the help of the hand. So you have to either use the you have to use the vibrating machine, or you have to give the simple tapping on the sides. But you shouldn't need to compress the mortar into the mold. Then before filling the mortar into the mold, you have to oil the mold properly so that the mortar doesn't get adhered on the sides of the mold. In the surface that you received after removing the mold should be smooth. And the standard size of the sand particle should be such that the sand should completely passes through 85 micron ISC, and not more than 10% of such sand should passes through 60 micron ISC. The mixing should be completed within 3 to 5 minutes, and after, if the time of mixing exceeds 4 minutes to bring the uniform color, the mixer should be rejected and the fresh mortar should be prepared. The cube should not be allowed to dry until they are broken, so that the hydration could continue. So this is all about the cement test. Let's move towards the concrete. So we are already familiar with the concrete. It is the second most consumed item on the earth after the water, and because it is relatively cheaper, it has high strength, it is moldable in nature, it is rather used in almost each and every application regarding the building construction and the pavement construction. Now, the concrete are usually exist in two states. If it is exist in the fresh states or green state, it is malleable in nature, and you can mold it into the suitable shape or sizes as you require. But after some times, it tends to gain the strength due to the hydration process of the cement, and then you couldn't mold it according to your requirements. So in a concrete mixes, there are two active components. The first one is cement, and first one is second one is water, which forms the paste and the matrix, which adheres to the fine and coarse aggregate, which provide durability, strength, as well as density to the concrete. Then fine aggregate and coarse aggregate are the inert ingredients that forms the skeleton in the concrete and provide the bulk of the concrete. They increase the strength as well as they reduces the shrinkage and the overall cost of the concrete. If you want to impart some special properties to the concrete, you need to incorporate admixtures to it. Admixtures can be of many types. It could be plasticizer, it could be super plasticizer, it could be air entering agents and other things, so that you can you can develop a concrete that would deliver a specific properties, or specific shows the specific physical and chemical properties. Then it is a job of a designer to determine the optimum type as well as the proportion of various ingredients, so that so that he or she can produce the concrete of the desirable quality, and this process is known as the concrete mix design. So we can classify concrete in a various ways. There are several different types of the classifications. Few major types of classifications I have already mentioned here. The first one is you can classify concrete on the basis of the cementing material. So based on the cementing material that provide the binding properties, you can classify concrete as lime concrete, gypsum concrete, asphalt concrete, and the most common one, cement concrete. Now, based on the grade, or rather based on the compressive strength of the concrete cube of the size 150 after 28 days curing, you can classify concrete as per its grade, such as M5, M7.5, M30, and so on and so on. So here M represents the mix, and say M and the numerals represent the strength, or rather characteristic compressive strength after 28 days of the curing. Then based on the perspective specification, we can classify concrete as the nominal mixed concrete or the design mixed concrete. So nominal mixed concrete is the concrete whose ingredients are more or less fixed, and it tends to deliver the desirable properties using that particular fixed type of proportioning. On the other hand, design mixed concrete is the concrete that the designer is producing by its own judgment to give a desirable to enhance or subside a particular type of a property. So up to M25 grade concrete, the mixes are comes under a category of nominal mix because their proportions are fixed, and above that the mixes are classified as the design mix. Then based on the bulk density, if the density of the concrete is greater than 2500 kg per meter cube, we classify the concrete as the super heavy concrete. If density falls in the range of 1800 to 2500 kg per meter cube, then it's dense. If it is in the range of 500 to 1800 kg per meter cube, comes in the category of light. And if it is below 500 kg per meter cube, it comes under the category of extra lightweight concrete. Now, based on the place of the casting of the concrete, concrete can be classified as the in situ concrete or the precast concrete. If it is casted on the site, comes under the category of in situ concrete. Now, based on the state of the concrete, we can classify concrete as the fresh concrete or green concrete and hardened concrete. Similarly, based on the compressive strength, low strength concrete, if the compressive strength is lower than 30 megapascal, if strength falls in the range of 30 to 60 megapascal, we classify it as the medium strength concrete. And if the strength increases greater than falls in the range of 60 to 100, then it is the high strength concrete. And if strength exceeds 100 megapascal, such concrete is called ultra high strength concrete. And finally, based on the purposes, we can classify concrete as pavement quality concrete, pervious concrete, dry rain concrete, self-compacting concrete, and so on and so forth. So these are the concrete that we are adopted for a specific purposes. If we talk the influence of the concrete or the requirements of the concrete in concept of the context of the pavement construction, so concrete pavements are considered far more durable than the other pavement types, specifically the bituminous pavement or the flexible pavement types. Although the cost of the concrete pavement construction is about 20% higher than the bituminous pavement construction, the concrete pavement doesn't require any maintenance, or the only maintenance they require is the maintenance of the joints that we usually construct to prevent the shrinkage cracks. So if we compare the overall performance, then the life cycle cost of the concrete pavement is about 25 to 35% lower than the flexible pavement. And since concrete pavement is a type of a rigid pavement, it doesn't deflect much. So due to the less deflection, the vehicle operating cost is also lower because vehicle tends to consume 10 to 15% times 10 to 15% lower fuel on concrete pavement than the bituminous pavements. Now, concrete can be utilized in the pavement as the bearing course or as a base course or also as an overlay. So as a bearing course, usually use the pavement quality concrete. In a base course, we use a rather harsher concrete or a stiffer concrete known as the dryland concrete. And as an overlay, we utilize concrete in the form of white topping. When we talk about the concrete pavement, we have four different types of concrete pavement. The first one is a jointed plain concrete pavement, which you usually encounter. Other than that, we have jointed reinforced concrete pavement, in which a small amount of reinforce is provided so that it could arrest the crack and doesn't allow the crack to expand further. And then we have continuous reinforced concrete pavement, in which no joints are there. And then we have pre-stressed concrete pavement, in which the precast slab has been utilized for the pavement construction. So the continuous reinforced concrete pavement and pre-stressed concrete pavements are usually not utilized in our country, and the majority of the cases we usually encounter with the jointed plain concrete pavement and jointed reinforced concrete pavement. As per the most specification, the flexural strength of the concrete should not be less than 4.5 megapascal for the standard case, or if you are constructing a national highway. However, if you are constructing a rural roads, IRC SP62 has recommended that 28-day compressive strength of the concrete should be at least 30 megapascal, and the corresponding flexural strength shall not be less than 3.8 megapascal. So, other than that, other than these concrete that I have already discussed, there are some emerging types of concrete such as self-compacting concrete, pervious concrete, and geopolymer concrete, which is also known as a no cement concrete. These are also gaining popularity in the pavement construction practices. Now, testing of concrete can be divided in two parts. The first one is the testing of the fresh concrete, and second one is the testing of the hardened concrete. So when we talk about the testing of fresh concrete, there are two major types of the quality check or the test which you need to perform. The first one is the workability test. The workability is the fundamental parameter that you need to consider while preparing the fresh concrete. And second one is the setting time. So workability is people often confuse workability with the term consistency or fluidity, but both are different things. Workability is a property of the freshly mixed concrete which determines the ease and homogeneity with which it can be mixed, placed, consolidated, and finished. Okay, so if we increase the water in the concrete, its fluidity will increase, but it doesn't mean its workability improve. Workability is rather the purpose-driven thing. So a concrete which is workable for one specific purpose may not be workable for some another purpose. Okay, so workability is rather more complicated thing, as it covers the multiple facets of the concrete mix technology, concrete construction technology. So it basically link the compaction of the concrete with the strength. So it is quite clear that the strength of the concrete is directly depending on its density, and density can be improved by providing the efficient compaction. So if the workability is suitable, then we can provide a good compaction to the concrete which results in higher strength. Okay, so but the concrete which has high consistency or which is more mobile doesn't need to have the right workability. So the concrete that you are using for the building construction may be workable for the building construction, but it may not be workable for the pavement construction. Then we talk about the setting time. So the time at which the concrete loses its plasticity is termed as the initial setting time, and the time after which it tends to gain some strength and you can apply some pressure over it, it is known as the final setting time. Now, people sometimes correlate the setting time of the cement with the setting time of concrete, but it is somewhat true, but it is not entirely true. The setting time of cement influences the setting time of concrete, but setting time of the concrete doesn't entirely depending on the setting time of cement only. As concrete has other components as well, such as what such as aggregates and admixtures. So in order to determine the initial setting time, you need to take consideration of these parameters as well. So you can't just directly predict the setting time of the concrete based on the setting time of cement only. So workability is more or less the major property that you need to consider when you do the quality analysis of the fresh concrete. And workability is depending on several factors. The first or the primary factor is the water content. So higher the water content per cubic meter of the concrete, the higher will be the fluidity of the concrete. Okay, but you should not incorporate water that much that concrete cause there is a possibility of bleeding. Then when we talk about the mixed proportion, as we increase the aggregate cement ratio, the concrete becomes leaner and the less quantity of paste is available for the lubrication. So if the less quantity of paste is available, then the proper density would not be achieved, as the aggregates could not be realigned on their proper places. So workability will reduce. Then if the size of the aggregate is increased, then the surface area that it offers would be lower. So as we increase the size, the surface area will be lower and the larger volume of the paste will be available for the lubrication. So workability will increase with the increase of the size of the aggregate. Then when we talk about the shape of the aggregate, angular and elongated and flaky aggregates make concrete very harsh. On the other hand, the rounded aggregate or the cubical shape aggregate provide better workability because they don't tend to interlock as well. Also, the voids are relatively less in the rounded aggregate or the cubical shape aggregate as compared to the angular, elongated and flaky aggregates. Then we talk about the surface texture. The aggregates which have the rough surface texture display higher surface area and exhibit poor workability. Similarly, when we talk about the gradation, the denser gradation means the concrete will exhibit lower amount of void, so the more amount of paste will be available to generate a lubrication and the workability will higher. And similarly, the use of the admixture. You all are already familiar with the admixture. The use of the plasticizer, super plasticizer, and air entrainment agent provide an additional lubrication and enhances the workability of the concrete. So the most common test which is used to determine the workability is the slump test. So slump test is used to determine the consistency of the concrete mix, and it is basically very important for the concrete mix which have the medium workability. So what is slump? Slump is a measure to indicate the consistency of workability of fresh concrete, and it is used to determine the water content to give a specified slump value. So if you go through the IRC 44, this slump plays a key role in the mix design process because we are taking water corresponding to a particular slump value. This slump value is usually 50 mm. So based on the slump, we are deciding our water content, and around the water content, everything more or less depending on the water content in the concrete. So what are the apparatus required? Apparatus that we need to require for the testing is obviously the slump cone. Other than that, we need spatula, trowel, clamping rods, and weighing balance, and also the graduated cylinder to measure the water content. Then the testing specification is 1199/1959. So, this is the brief procedure. In order to perform the slump test, you need to clean the internal surface of the mold through a moist cloth, and after that, you need to apply a small layer of oil into the internal surfaces, and then you have to place the fresh concrete sample into the slump cone in 4 layers. Each of the layers should be in approximately same size. The height of the slump cone is 300 mm, so each layer should be roughly around 75 mm. Then each layer should be tamped 25 times with the help of the tamping rod, You have to distribute the you have to distribute the strokes uniformly over the cross section surface, cross section. And after that top layer, rodding of the top layer, you have to strike off the excessive mix by horizontal movement of the tamping rod. And after that, you need to lift the mold completely by raising it slowly, and you have to make sure that you should not have any horizontal motion during the lifting of the mold. So as you lift the mold, concrete tends to subside, and you have to measure the difference in the level of subsidence between the height of the mold with the highest point of the subsided concrete, which is this point. So this is very important. You have to measure the subsidence from the highest point itself, not from the lowest or any middle point. This is quite important. So the subsidence of the concrete in mm, you can call it as the slump of the concrete. While measuring the slump, you have to take some considerations in mind. First one is, and slump, these are different types of the slump that you can encounter. This is the true slump, in which the sample usually bulges on the outside. On the other hand, this is the zero slump. So if other than that, if you encounter the shear slump or the collapse slump, you need to discard the sample, and only true slump should be reported as the final reading. During the lifting, you should lift very slowly, remove the cone very slowly, and you should not disturb the concrete sample. Another thing is that you should complete the test within 3 minutes so that the setting doesn't start in the fresh concrete. Other than that, any surplus concrete should be carefully removed with the trowel, and you should not force feed the sample into the slump. Then this test is suitable for only for the medium slump with the high and medium to high workability. It means the sample which showed the slump between the range of 25 mm to 125 mm. And this slump test is limited to a concrete with a maximum aggregate size lower than 40 mm. Then the another type of the test for the measurement of the workability of concrete is the compaction factor test. In the compaction factor, this test is usually preferred for the concrete specimens that shows very low workability or very low slump value. So it is based on the principle that workability is the property of concrete which determines the amount of work required to produce full compaction. So if the amount of work required is less, then concrete is said to be more workable. So this is the standard compaction factor apparatus. You can perform this test on field as well as in lab. So to perform this test, you have to put you have to place the concrete sample gently into the upper hopper up to its brim. You have to clean the sample which is outside the brim, and then with the help of the lever, you have to open the trap door. So when you open the trap door, you have to make sure that the trap door of the lower hopper should be closed completely. So when you open the trap door, the sample you fall down to the bottom hopper, and after that you have to open the bottom trap door, and after that the entire sample will fall down to the standard mold. Now, after when it sample moves to the bottommost mold, you have to during the entire process you have to give simple tapping if some sample is stuck onto the upper hoppers, so that the entire sample should shifted to the bottommost mold. However, if there is some sample which is in excess, you have to remove this sample from the analysis, and you have to clean the sides of the bottommost mold completely. When you clean the after you clean the sides of the bottommost mold, you have to measure the weight of the specimen plus the mold, cylindrical mold. After that, you have to clean the cylinder completely, and then measure its empty weight. After that, you have to make a fresh sample, and then you tends to fill this cylindrical mold completely with the fresh sample by providing the heavy compaction using the tamping rod. You attempt to fill this cylindrical mold with as much concrete as it is possible. After that, you just finish the sample off, finish the top surface, and then measure the weight. So basically, what we are trying to do, we are trying to calculate the ratio of the weight, which can be which which can be inserted into the sample by the influence of the gravity, and then we are taking and we are dividing that weight with the weight of the sample that we can provide with providing the force compaction of the concrete sample. So compaction factor would be W1 minus W divided by W2 minus W. So what is W1? W1 is the weight of the partially compacted concrete specimen. W2 is the weight of the fully compacted concrete specimen, and W is the weight of the empty cylinder. So if the compaction factor is high, it means that the concrete is more workable. But if the compaction factor is low, then the concrete is less workable. So compaction factor test is basically more sensitive for the laboratory testing of the concrete, which shows the lower slump values. So it is particularly good for the concrete mixes having medium to low workability. And for the pavement quality concretes, which usually shows a slump in the range of 0 to 25, the compaction factor comes in the compaction factor displays the value more or less near to the 0.78. On the other hand, for the slump value of 25 to 50, the compaction factor comes out to be near about 0.85. And these two concrete we usually use in the pavement construction. There are some other workability tests such as VV consistometer test, K-slump test, flow table test, and Cali-wall test. But these are not very popular as compared to the slump cone test and the uh, compaction factor test. So we are not going to discuss this. Then we have the initial setting time and final setting time test. So initial setting time and final setting time test, as per the IS specification test, IS specification 1199 part 7, you used to determine the initial and final setting of the concrete mix using the penetration resistant apparatus. So this is the penetration resistance apparatus, and you need to provide different arrangement or different needles, and based on the resistance which is offered by the needle, you have to calculate the resistance, and based on that resistance you have to determine the setting time. So the time after which the concrete shows the penetration resistance of 3.5 megapascal is known as the initial setting time, and the time after which the concrete is starting to show the resistance of 27.5 megapascal is known as the final setting time. So we need to perform this test using the cubical mold of the lateral dimension of 150 mm. You need to have the penetration testing apparatus along with the different needle arrangement of different sizes of ranging from 645 mm square to 16 mm square. Other than that, you need pipette to remove the excess water or to remove the water which comes out of the bleeding, and tamping rods and thermometer. So what you have to do, first you have to make a representative sample for the testing. So in order to make the representative sample, the mix that you need to, the concrete mix whose initial and final setting time you need to determine, you should sieve this mix through 4.75 mm sieve, and you have to extract the quantity and the material that passes through 4.75 mm sieve or mortar which passes through 4.75 mm sieve should be used for the testing. The quantity of mortar should be such that the depth of the mold up to 140 mm should be filled. The testing should be done at the temperature ranging from 25 to 31 degrees Celsius. So the mortar that you have taken in the assays, you should fill that mortar in a concrete mold up to in three different layers, and then you have to tamp each layer as you have done for different testing. So what you have to do, you have to leave some gap before, and you should not have to fill the mold up to the brim, because when concrete tends to set, when the mortar tends to set, some water tends to appear on the top surface, and you have to remove that water with the help of the pipette. So you have to leave some space for that. So preferably at least 13 space from the top surface should be leave, so that the water should be can be removed with the help of the pipette. Now, usually the first reading of this test is taken after 2 hours. So what you have to do after the 2 hours, you have to attach the arrangement. You have 6 different types of needle arrangement. So the needle which have the largest surface area, which is largest cross section area, which is 635 square, you have to attach that needle into the penetration resisting apparatus, and then provide a forces, so that the needle penetrate up to the depth of 25 and you have to record the force required for the penetration of that particular needle to up to the depth of 25 Okay, so you have the penetration resistance, you have the area, so you can, you have the force, you have the you have the surface area, so you can directly calculate the penetration resistance by dividing the force with the surface area. So after the calculation of the penetration resistance, you have to wait for half an hour, and after half an hour, you have to apply another arrangement attachment, and then you have to perform the test again. So you have to take 6 to 10 readings, and surface of the mold will be look something like this. So after taking 10 readings or 6 readings, minimum 6 readings should be taken, but if it is 10 reading, it's better. You have to determine, you have to plot a curve between the penetration resistance and the elapsed time, and after the plotting of the curve, the time corresponding to 3.5% of the penetration resistance is can be considered as the initial setting time, and the time corresponding to the penetration resistance of 27.5 megapascal can be corresponding to the final setting time of the concrete. Okay, one small thing you have to take in mind while removing the bleeding water before conducting the test, you should not disturb the surface of the you should not disturb the solid surface of the set concrete. Now let's move to the testing of the hardened concrete. So there are various properties by which the quality of the concrete can be determined or assessed, such as strength, impermeability, durability, shrinkage, creep, elasticity, thermal property, and fire resistance. However, the property which directly affect the quality of the concrete is the strength. So we will focus our attention on that only. So what are the factors which are affecting the strength? The first and foremost most important parameter is water cement ratio. So as per the Abraham's law, the strength of the concrete is inversely proportional to its water cement ratio. So as we increase the water cement ratio, the strength will decrease. Then aggregate cement ratio, the compressive strength of concrete increases with the increase in the aggregate cement ratio, provided the workability is properly maintained. Okay. Then talk about the cement content. So the compressive strength will increase with the increase in the cement content. Then the age of the testing. This the rate of increase of strength is usually higher uh, during the initial phase of the concrete. Uh, However, the rate of the strength gain becomes lower as the age increases. Then the compaction. If you provide the adequate compaction, density would be higher, so the strength would be higher. Then the curing. The concrete most usually gains its entire strength within sorry after the concrete usually gains 90% of the strength that you are about to gain after 28 days of the curing in within first 7 to 14 days. After that, the rate of gain of strength becomes lower, and about 10 to 20% of the strength increases if you test the strength after 1 year, say 1 year or 6 months. So There can be different strengths such as compressive strength, tensile strength, shear strength. But the compressive strength test is the most fundamental of the test because it is quite easy to perform. It is quite difficult to perform the direct tensile strength test for the concrete. Although for the design of the pavement, we need to take tensile strength into consideration, or rather flexure strength into consideration. But since direct tensile strength cannot be determined very easily, you have to determine uh, tensile strength with the help of the flexure test, compressive test, and there are several relationships exist between different properties. So you can use that relationship to determine the strength that you are required for the pavement construction. So the most fundamental test of the concrete is hardened concrete is the compressive strength test. So compressive strength test, basically compressive strength test, if we talk about the compressive strength test, we are talking about the characteristic compressive strength test. So characteristic compressive strength test is compressive strength is the strength corresponding to which not more than 5% of the test results are expected to form. So when we say characteristic compressive strength, and we are talking, if we are producing 100 specimens, then at least 95% of specimen should exhibit strength greater than we have already specified. Okay, then only we can say the quality of concrete is good. Now, compressive strength, there is a direct relationship between the compressive strength and the flexural strength. So, with the help of the compressive strength, we can estimate flexural strength as well. Compressive strength is basically 0.7 times the under root of the flexural strength. Flexural strength is zero point 0.7 root FCK, or zero point 0.7 times the under root of flexural strength, compressive strength. So, compressive strength test can be performed using cylindrical specimen of size 150 by 300 mm, or with the help of the cubical molds of size 150 by 150 by 150 mm, or also with the help of cubes having size 100 by 100 by 100 mm. Other than that, you can also perform compressive strength test by cutting the beams which you have if you have casted the beam for the flexure strength test, then the ends of the beam can be cut, because usually deformation doesn't occur at the end of the flexure test. So you can just cut the beams and you can perform test by using their specimens also. So you have quite flexibility to perform the compressive strength test. The testing specification is usually IS 516 1959, and usually representative concrete sample should be taken for the casting, should be taken as cubical sample as well as the cylindrical sample. Now, if you are performing the testing with the help of the cubical specimen, then you have the similar to the cement specimen, you have to perform the test, you have to apply load by turning by on the turning sample to the sides, because we have to avoid the eccentricity. But if you choose to perform the testing with the help of the cylindrical specimen, then you need to, in order to prevent the eccentricity of the loading, you need to provide a capping to the concrete samples, and this capping can be provided by with the help of providing a thin layer of a cement, or with the help of the sulfur mixture consisting 3 part of sulfur and 1 part of the inert filler such as fire clay. Also, other than that, you can also provide the capping with the help of the hard plaster as well. So similar to the other testing, the testing should be performed at 27.2, 27 plus minus 2 degrees Celsius. You have to cast the specimen. During the casting, you have to make sure that the molds are proper, whether it's a cylindrical mold or whether it's a cubical mold, it should be properly oiled. Then the tamping should be properly done in the the filling should be done in the equal layers of 3 to 4 layers. The tamping should be done properly, and then after that, after the completion of the filling of the specimen, the specimen should be covered with the Hessian cloth, wet Hessian cloth, and should be left for 24 hours. After the 24 hours, the sample should be extracted from the mold and then directly transferred to the uh, water tank, in which quality of water should be portable in nature. And if you are performing test for a strength for a curing period higher than 7 days, then for every seven, when after each 7 days, you have to change you have to change your water so that its quality is maintained. So if you are testing, also before the testing, you have to provide the capping, as I have already told. The capping should be properly horizontal, so it should not be, its level should be properly horizontal. So in order to check that the level of capping should be properly horizontal, you have to use the label bubble tube, so that no eccentricity should be present. The load After that, the loading shall be applied without the shock and increase continuously at a rate of approximately 140 kg per centimeter square per minute. So load is increased until the specimen is filled and maximum load should be noted. And the compressive strength is maximum load per unit area of the cross section of the specimen. So also there is a small consideration you should take in, a small point that you should take in consideration. The compressive strength is depending on the height by diameter ratio. So if you are doing testing for a, if you are if you are going to test the force that you have collected from the field, you have to check their height and diameter. If the height by diameter ratio is very high, then in the ideal case the height by diameter ratio should be 2. But if the height by diameter ratio is high or greater than 2, then you have to apply a correction factor to it. Usually if the height and diameter ratio is greater than 2, the actual strength tends to be lesser than the strength you get. Sorry, the strength that you get should is usually lower than the actual strength. So by applying a compacting factor lower than 1, the actual strength comes out to be high. So this here you have to take in consideration. There's a relationship provided in the IS 516 specification which you need to follow while calculating the strength of the compressive strength of the concrete in case of the cylindrical specimen. While calculating the average load, if any individual variation from the average is more than 15%, then the test result should be rejected and the test should be repeated. So the difference between the result should not be exceed 15%. Then the second test is the flexural strength test, which is a key test if we consider the design of the rigid pavement. So in this test can be performed with the help of the prismatic beam specimen of the size 15 by 15 by 70 centimeter. In case the aggregate size is less than 38 mm, if aggregate size is less than 19 mm, then you can also utilize the sample of size 10 by 10 by 15 mm. Other than that, tamping rod we need to require, and bucket base plate and flexible testing machine we need to provide. Now, in this, you can perform the test in two way. Either you can perform the central loading or you can perform the third point loading, as I have already shown in the figure. Now, similar to the compressive strength test, you have to fill the concrete into a mold in 3 approximate equal layer, and each layer should be tamped 35 times. The beam, the circular rollers should have the cross section of diameter 38 mm to provide the support to the loading points, and the distance between the outer rollers of the span should be 3D, where the distance between the inner rollers would be the D. So in this way we are applying one loading at 1/3 distance. Okay, and the loading are equally and the rollers are equally spaced. Then the specimen stored in water should be tested immediately on the removal from the water while they are still wet. This condition should you have to follow for each and every specimen. Then the loading should be applied at a rate of 400 kg per minute for 15 centimeter specimen and at 180 kg per minute for 10 centimeter specimen. And then flexural strength can be calculated by applying the beam formula, that is moment upon the section modulus. So flexural strength comes out to be WL by BH square, and all strengths are comes out to be in megapascal. During the testing, at no account, the sample specimen should be allowed to be dry, and even and sorry, and when received dry should be kept in the water for 24 hours before testing. Then you have to not force feed the sample into the mold. And then, as per the IS 456, there is a relationship existed between the flexural tensile strength of the concrete and its compressive strength is FCR equal to zero point 0.7 root FCK, where FCR is the tensile strength of concrete. Now, split tensile strength is an indirect way to determine the tensile strength of the concrete by subjecting the concrete to a compressive strength. So it is relatively simple test, and it could be done with the help of the arrangement that we have already provided for the compressive strength test. So not additional flexural testing machine is required to perform this test, and with the help of compression testing machine you can easily perform this test. And some studies reported that it gives much reliable result as compared to the flexural beam test. So the apparatus requires the compression testing machine. Then in order to provide uniform loading, you need to pack, you need require two bearing strips or the packing strip. Other than that, if you want, you can also provide the supplementary steel bearing bars, so that load can be determined, can be distributed uniformly. The cylindrical mold will be the same, of the diameter 150 mm and the height 300 mm. And then tamping rod and other arrangement is required. The testing specification is IS 5816:1999. So you have to prepare cylindrical test specimen following the procedure that you have followed in the compressive strength test. Then after the preparation and the curing, you have to draw two perpendicular lines, and along this line you have to apply the load. Diametric lines, these are the diametric lines. Okay. Then you have to measure the length and diameter of the specimen. After that, you have to apply loading via plywood strip and the supplementary steel bars. So plywood strip should be two pieces of plywood strip should be applied on the top and the bottom end, and align the specimen in a way along the lines that you have already marked. And then if supplementary steel bars is required, then after above the plywood strip you have to provide the supplementary steel bar, and you have to provide the compressive load. Now the rate of the compressive load will depend on the size of the specimen, but you have to basically provide the tensile stress in a range of 1.4 to 2.1 megapascal per minute, and until the failure you have to apply that particular load. And at that rate you have to record the breaking load, and then split tensile strength can be calculated using the formula that is given, which is 2p into 1000 by pi dl. What are the points we have to consider? The first, the length of the specimen should not be less than the diameter and not more than the twice the diameter. So the ratio of the strength and diameter, ratio of the diameter and height should be maintained properly.